Hi everyone, my name is Travis Cook, and this is Group 12's project proposal for the Band in a Box project. For this presentation, there will be an accompanying PowerPoint presentation that will be used as visual aids, and the PowerPoint slides will be called out by number when referenced. For this project, each team was to design a set of at least 3 musical instruments, comprised of 1 wind, 1 string, and 1 percussion instrument that will all fit together within a 2-foot cube, with each instrument costing less than $15. Additional requirements and constraints, including those that were just mentioned in the problem statement, are that the set of instruments must have at least 3 instruments, 1 wind, 1 percussion, 1 string instrument. Each instrument must cost less than $15, and together they must be able to play one of 3 specified songs. The teams were to use no more than 10 feet of pipe, no more than 6 feet of guitar string or piano wire. All instruments must fit in a 2-foot cube, and 1 instrument must be able to play 2 parts if your group only has 3 instruments. The top design goals for this project were that, most importantly, the specified song must be able to be played, and also the instruments must fit together within the 2-foot box. For this project, Team 12 came up with 3 different designs, with Design A being the string instrument responsible for the low range of the notes, the percussion responsible for medium, and the wind instrument responsible for the high and medium high. Design B was with the percussion instrument responsible for low, wind for medium, and string for high and medium high, with Design C being the wind instrument responsible for low range, string for medium, and percussion for high and medium high. All 3 of these different designs had varying instruments with different materials being used for each. And based on the decision matrix on slide number 5, the criteria of functionality, size, material use, and cost were all weighed against each other, with Design A winning out as being by far the best, and therefore the one that was used by Group 12. For the percussion instrument, the design, as can be seen on slide number 6, is similar to that of a wooden xylophone, comprised of 1 by 2 foot lumber blocks cut into varying lengths, the longest being 24 inches, and each successive block being 1 inch less. As can be seen on slide number 7, the equations that were used in order to find these bar lengths were as, again, seen on slide number 7. The first equation, equation number 1, is the equation that is used to determine the fundamental frequency of a note in a rectangular bar percussion instrument. Equation number 2 is that same equation rearranged to find the length needed based on a certain frequency. And the third equation is the equation used to find the K factor of the bar depending on its thickness. The frequencies for the notes were found on the project documents, and the various numbers were plugged into those equations to find the bar lengths as seen on slide number 8. On the table on slide number 8, there is the bar length, and then there is another column called the supported bar length. And as for percussion instruments, the note is based off of where the actual bar is supported. That is what the supported bar length is. The actual bar length will be a little bit longer to allow for the string that will be used to tie the bars down to be able to do so. Also, for the percussion instrument, on slide number 9, there is a breakdown of the material costs, and with the total cost coming to $10.07. Now to talk about the proposed design for the string instrument, here is Joshua Koob.
My name is Joshua Koob. I'll be going over string instruments. As you can see, this is my 3 drawing view of my string instrument. It has a neck that's made out of wood, which is 13 inches long, and a base made out of a plastic container, which is 11 inches long. Here's the 5 equations that I use to determine what type of string tension and length that need to be. Equation 1 alpha, 1 bravo, and 1 charlie was for mass density. By using the mass density, I plugged it into equation 2 alpha to get the tension for each of the 3 strings. and then using equation 2 Bravo with the mass density and the tension, I found out the length to play that note. As you can see, here's the breakdown of all the measurements. This string instrument is very cost effective. The wood for the neck is $2. The plastic food holder, which is going to be $2 too, and then tar string, which would be $6. A total of $10. I'll be followed by Jonathan with Wind Instruments.
Thank you, Josh. My name is Jonathan Kuhn. The final instrument of the design is a wind instrument. This instrument has been designed to play both the high voice and the mid-high voice. The first step in creating this instrument was to look up the notes that are required to play Ode to Joy. Since this instrument needs to play 2 parts, it required a total of 8 notes. In order to figure out how long the pipes need to be to play these notes, a simple mathematical formula needs to be followed, shown here. Next, you will see the frequency of each note that is required. When you plug these numbers into the previous formula, you get the lengths shown here. As a quick example, when you plug the frequency for A4, which is 440, into the formula, you get a total of 19.52 centimeters. This instrument is made almost entirely out of PVC pipe, making it inexpensive and lightweight. The dimensions needed for the instruments are shown here in the 3-view diagram. The entire instrument is about 8 inches by 11 inches, thus easily fitting into a 2-foot cube. The total cost of the flute comes in under the required cost at $14.63. And these are what we used as reference points. Thank you very much.